Friends, welcome to my YouTube channel. Dhanesh here at another interesting session in machine learning. Today we are going to discuss about left tail test, right tail test in hypothesis testing. Let's start. This is an interesting quote from Albert Einstein. Once you stop learning, you start dying. We will start now. In this video, I am going to discuss about left-tailed, right-tailed and two-tailed hypothetical testing. In the last video, we discussed about hypothetical testing. I am giving a quick introduction to hypothetical testing in statistics. It's introduced by Ronald Fisher, Jesse Neyman, Carl Pearson, Pearson's son, Egon Pearson. You might have heard of, Pearson correlation coefficient. We have a separate video on correlation coefficient in statistics. Under the playlist statistics, it's available. You can watch that video. Hypothesis testing, first I am telling you what is a statistical hypothesis. A statistical hypothesis is an assumption about a population parameter. You are familiar with population and sample. There is a video on population and sample under the playlist statistics. You can watch that. You need to understand all these concepts. It's very important for machine learning. These concepts in statistics is really important. This assumption may or may not be true. So a statistical hypothesis is an assumption about a population parameter, and this assumption may or may not be true. Hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. Hypothesis testing is basically an assumption that we make about the population parameter. Now you need to understand null hypothesis. It is denoted by H0. Null hypothesis is a statistical hypothesis that assumes that the observation is due to a chance factor. That is null hypothesis. Alternative hypothesis, it is denoted by H1, or sometimes people will use the letter H suffix A. Both are correct. H1 or HA, alternative hypothesis. The alternative hypothesis shows that observations are the result of a real effect. We are coming up with alternative hypothesis by experimental facts. After analyzing the experimental results, we are coming up with alternative hypothesis. This example will give you more clarity on null hypothesis and alternative hypothesis. Let us consider the example of tossing a coin. A null hypothesis might be that half the flips would result in heads and half in tails. That's the null hypothesis. The alternative hypothesis might be that the number of heads and tails would be very different. We can represent mathematically if probability is 0.5, that is the null hypothesis, and it is not equal to 0.5, it is the alternative hypothesis. Suppose we have done the experiment and we flipped the coin 50 times, resulting in 40 heads and 10 tails. Given the result, we would be inclined to reject the null hypothesis. Then, based on this experimental fact, we have to reject the null hypothesis. That's all. Then we would conclude, based on the evidence, that the coin was probably not fair and balanced. It's not balanced and not fair. That's the conclusion we can make. So you understood what is null hypothesis and alternative hypothesis. What is a tail in hypothesis testing? A tail in hypothesis testing refers to the tail at either end of a distribution curve. So you are familiar with the Gaussian distribution, or we call it as the normal distribution or bell curve. All are same. So this is the shape of the normal distribution. All right, so these two we have a separate video on Gaussian distribution under the playlist statistics. You can watch that. These two areas we call the tail of the Gaussian distribution or normal distribution or bell curve. This is the mean. This central point, we call it as the mean. It is denoted by the Greek letter mu. You are familiar with this. How we will get this, critical points? These points be based on the Z score. Here we will use Z score or IQR score, interquartile range, or box test. See, you have the box test or whisker test. All these, for detecting outliers, we will use all these scores: Z score, IQR score, box test, or whisker test. So we have videos on these, even in feature engineering, under the playlist feature engineering and statistics, you can watch these videos. What I am trying to say is, anyway, the Z score determines the critical point. This is the critical point. This is minus Z and this is plus Z. So based on those values, we can find out the critical points, and after that, this area we call it as the tail in the Gaussian distribution or the normal distribution, or this is the tail in the hypothesis testing. You understood what exactly? So for example, if you want, let us consider the example of lifespan of a group of people. What's the change we are getting after the lifespan, after a lifestyle change? So they have, we are analyzing, let us consider the analysis. Okay, we are considering the analysis of the lifespan of a group of people after a lifestyle change. If the lifespan is greater than the original, see, after the lifestyle change, the lifespan is greater than the original. Let us say the original is 75 years. This is the original lifespan. So your hypothesis statements might be: null hypothesis is no change. The lifespan is H0 is equal to 75. This is the null hypothesis. Alternative hypothesis is the lifespan has increased, after the lifestyle change. You got it? The null hypothesis is H0 is equal to 75. There is no change. Alternative hypothesis is after the lifestyle change, the lifespan has increased. That is the alternative hypothesis. Now we have the two-tailed test. This is the two-tailed test. Here you have these two areas. This is the two-tailed test. This is the mean. Mu is the mean. Mean is the mu. Greek letter mu. This is minus Z plus C. These are all the critical values. What is minus Z and plus Z? This is known as the Z score. You have to understand, if you want to understand Z score, it is a very important term when we do the outlier detection in machine learning. Is Z score, IQR score, box test or whisker test. Please watch those videos under feature engineering or statistics. Both the playlists, it's available. So these two critical values, minus Z and plus Z. So these two areas, we call it as the tail. This is a two-tailed test. Here the condition is, see, mu, the mean, is not equal to 75. See, the null hypothesis is mu is equal to 75. So in the alternative hypothesis, it is not equal to 75, means it can be greater than 75 and less than 75. Both the things, it's possible. That is a two-tailed test. The lifespan after the lifestyle change, some of the people, the lifespan has increased, and some of the people, the lifespan has decreased. That means it is not equal to 75. That is a two-tailed test. You got the point? So mu, mu is not equal to 75. So that is the alternative. For alternative hypothesis, it is HA. Here mu is not equal to 75. The parameter is not equal to 75. That is a two-tailed test. When it comes to the right-tailed test, it is greater than. For alternative hypothesis, mu is greater than 75. The mean value is greater than 75. So that case we call it as a right-tailed test. This is the right-tailed test. This is the z value. This is the plus z, and this is the minus z. So this is a right-tailed test. For a left-tailed test, again the alternative hypothesis, the mean is less than 75. That is the mean value is less than. This is a left tail test. If it is less than, it is left tail test. If it is greater than the mean, it is a right tail test. So after the lifestyle change in the alternative hypothesis, the mean value has decreased. Then so that is a left tail test. You are getting the point. So that is a left tail test. Now I am discussing about p-value in this video. That is probability value. A p-value is used in hypothesis testing to help you support or reject the null hypothesis. Based on the p-value, you will support or reject the null hypothesis. The p-value is the evidence against the null hypothesis. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis, and the more important your experimental results. It's very important. The smaller the p-value, the stronger the evidence you should reject the null hypothesis, and you should stick on to the experimental results. Very important. This is a very good, very nice table. You can understand everything based, related to p-value. See, if p-value is small, alternate hypothesis strong, null hypothesis weak. If p-value is high, alternate hypothesis weak, and null hypothesis strong. Very nice table. From this, everything you can understand. See, this is p-value and right tail test. See, this area is the p-value. This is the minus z. This is the critical value, minus z. This is plus z, and this is minus z, and this is the mean mu value, right? So this area of the tail, this area gives the p-value. Graphically, the p-value is the area in the tail of a probability distribution. This right tail, the area of the right tail gives the p-value. It's calculated when you run hypothesis test and is the area to the right of the test statistics. In the right tail test, the area in the right area will give the p-value. Here, how do you get this critical point? Plus z value. Well, z is the z score. I have already explained. When you talk about the left tail test, see, this is the p value. This area will give you the p value, probability value. So this is minus z and plus z. So that is for the left tail test. In the right tail test, this area will give you the p value, probability value, right? So this is really simple. It's very interesting concepts, and it's really simple. This is the p value. So that area is the p value when we talk about the right tail test. When the two tail test, these two areas represents the p value. These two areas will represent the p value. That's what the p value for two tail test. So this is the concept of p-value. P-value means is used in hypothesis testing to help you support or reject a null. Based on the p-value, you should support or reject the null hypothesis. That's the most important point. And this will clearly explain. So if the p-value is small, you should reject the null hypothesis. If p-value is high, you should reject the alternate hypothesis. Very simple. I'm giving a very important result. This is the final conclusion. If p-value is less than or equal to 0.05, that means 0.05 means 5%. reject the null hypothesis. That's all. This is strong evidence that the null hypothesis is invalid. If p-value is greater than 5%, 0.05 means greater than 5% means alternative hypothesis is weak, and you do not reject the null hypothesis. You shouldn't reject the null hypothesis if p-value is greater than 0.05. That's all about p-value. Thanks for watching. Please like, share, and subscribe. Thanks a lot.